So that you just kind of remembered that word problems, you weren't looking at like a word problem? Well, there you go. So there must be a specific problem when they're right.
10 AB.
Oh.
Oh my God. Why would you do that?
Brittany, right?
What?
Sure.
I mean, when you have kids, you're like, give me a hug.
All right, guys, so questions from the test on number 10. The funny thing is, students sometimes don't understand when I say this, but that's not really a word problem. A word problem is where you have to create your own equation. So I know it seems like I'm using semantics here, but that's a problem that's got words in it, but there's a definite process for doing it. It's not like you have to come up with your own equation to solve it. So this one I tell you, set up a proportion. So first off, what the heck is a proportion? Yeah, what's a proportion? Two ratios that are equal to each other. I like it. So, for example, here's a problem like the one I gave you, number 10, because there were like 4 different versions of the test. I don't want to do any one specifically, that would be unfair. So if I could, if I can cut, let's say, 33 tomatoes in half in like, what'd you say, Jeff? In like 10 minutes. Alright, so I can cut that many tomatoes in 10 minutes. Sounds slow, but oh well, that's me. I got traumatized because I cut my finger once, so I gotta go slow. And if you give me 18 minutes, how many tomatoes can I cut? Alright, so that's the same kind of question you all had on 10A. Some of you guys were chopping onions. Some of you guys were peeling carrots. I can't remember what else. Y'all felt like you were in the Navy or something.
Cucumbers.
Cutting your cucumbers, maybe. All right, could have done that. So what's one ratio that I can set up from the very beginning?
Fraction? I don't know.
The ratio is a fraction. So what fraction can I set up from this information that I gave? Per 10 minutes, how many tomatoes can I? 73.
10.
Tomatoes per 10 minutes. So the most common mistake people made was you chose a way for the units to line up and then you just went and forgot that way. But when I go to set up the other fraction, it's got to be the same way, right? So which part here do I know for the question? Give me 18 minutes, so where do I put 18? On the bottom, because that's where I already set up, that's where minutes are supposed to go. So if you would have done this one this way, then the 18 would have been on the top. But you've already picked where the minutes go. So the minutes go down there. How many tomatoes can I cut? Well, that's the question. So what do I put up top? X. I love it, because I don't have a clue how many tomatoes. So a proportion is two fractions that equal each other.
Why did you put the X over the top again?
So I put 73 there because I know how many tomatoes. 10 minutes because I know that's how long it takes to cut those, right? 18 minutes is how much I gave. How many tomatoes? So that's why I put an X there. I don't know how many tomatoes. And of course, now that I got that set up, how do you solve this? Yeah, so you would get 10X there. That's cool, right? Equals 18 times 73. Whatever that is. 13, 14 is that? 13,
13, 14.
13, 14. Had to Rain Man that for a second. Definitely 13, 14. You guys see where this is? I didn't get a lot of people that did the cross multiplication wrong. Most people just set this up wrong. Which part are we losing at, Jackie?
I'm thinking, I don't know.
But no, so you're cool with the 73 tomatoes in 10 minutes. So how many tomatoes
It's just
in 18?
a stupid mistake. I just straight up multiplied 73 over 10. I just multiplied it by 18. That's what I got wrong.
Oh, okay. So maybe you didn't set this up. You're just gonna guess
I didn't
what
put
to
the
do.
X. I didn't put the fraction.
Oh, okay.
Yeah, I set mine upside down. I had my X on the bottom.
And again, if I would have put 10 up top and 73 on the bottom, then that would be right. But the units are what sets up where they go.
Right.
So if I put tomatoes over minutes, it better be tomatoes over minutes.
Yeah, over
I like
minutes with that, the M and the M need to go together regardless.
Okay.
The minutes.
They got to be in the same place.
It's fine if you multiply 18 and then 73. Because they have different units though.
Oh yeah, I like it. Well, when I multiply 18, now watch. If when I multiply 18 minutes up here, don't the minutes cancel?
But if you multiply it, it doesn't matter. If you add it, it's different. I think that's what you're saying.
So you can multiply things with different units. Of course, we do that all the time. If I make $5 an hour mowing lawns, right, and I work for 3 hours, I'm going to multiply 5 times 3, even though they have completely different units, right? Because that's how the math is going to work. But then the units cancel down, so I end up with money, right? Maybe.
Okay, so you just said the M, the 10, and the 18 would cancel each other.
So if I did multiply this side, now watch, this is kind of neat because you brought up the units thing, right? So if I do multiply both sides by 18 minutes, don't the minutes cancel?
Yeah.
And what am I left with? Tomatoes, right? So that's why the answer is going to be so many tomatoes. That's the only unit that's left. So we don't normally drill that deep. Today we're going to be doing stuff related to this. So that's why I'm okay with doing that right now. But I like that you're worried about the units. It's beautiful. You should be worried about the units. And this is why it makes sense, because those minutes, you don't want the answer to have any minutes in them. I don't want tomato minutes. What is a tomato minute? I'm going to take tomato minute. Oh, yeah, tomatoes. Oh, so, I don't know what that would mean. So please tell me, you should not need a calculator for this. How do I divide by 10? I just move the decimal.
I just figured that out.
Don't be doing it. You didn't figure it out, then the calculator did. You should be able to figure this out without a calculator. You just move that back once, 131.4.
But why? Never mind.
Well, it's a good question to ask if you don't know why, because you got to know how to do this.
It's 10.
Yeah, it's 10. So when you multiply something by 10, doesn't the decimal move over once?
Yes.
So when you divide by 10, it's going to go back.
Right.
So multiplying by 100, we know this from percentages and decimals. Multiply by 100 moves it over twice. Dividing by 100 moves it back twice. So if I multiply by 1,000, it's going to move it over 3 times, and then so forth. However many multiples of 10 you do,
I'll make a
it's
note.
once each. It's a good note to make.
Yeah.
All right, cool. How are we doing? Today I got the middle of my jigsaw filled in. That's really weird. The outsides are kind of bare. All right. So 131.4 tomatoes. Okay, cool. Anything else left over from the test or left over from homework before we get into new stuff? All right. So today, like I said, we have a couple of sections left over at the end of chapter 7. So we've got 7.4 and 7.5. 7.4 is going to go a little bit quickly. 7.5 is going to take a little bit, because 7.5 we're going to talk about units. We're going to talk about metric units. Oh crap, right? So we'll get there. We'll get there. So 7.4 gives us a couple more properties. So for example, we already know commutative property, associative property, distributive property. So today we're going to talk about a couple things. One of them is called the identity property. And there's two of them really. So what's that word identity mean? Besides a really good John Cusack movie, Identity. If you ever seen it, you know what I'm talking about. If you haven't, then Google it. It's good. Additive identity. Identity is who you are. Right? So a number has an identity. Like 7 is 7. If you add 1 to it, now it's become some other number. Right? That's freaky. It changes personality entirely.
That's not true.
So why is that? If you add 1 to 7, what's it become? 8. That's a totally different number. Holy crap. Did it preserve? So adding 1 to a number, does it preserve that number's identity? No. 7 plus 1 becomes a different number. So what would the additive identity? It must be the thing that keeps its identity the same. What do I add to something so it stays the same? 0. So on one level it's kind of like, well, yeah, of course it doesn't change. But on another level, that's why we call it this. That's why we call it identity. So the additive identity is 0, because, for example, 4 plus 0 is 4. Negative 7 plus 0 is negative 7. So I want the word to make sense. Why math people chose that word? I want that to make sense. 0 is the additive identity because it's what I add to something to keep it the same.
So,
Nothing difficult there, just a new word to know.
it's like if you put like 2 over 1. Maybe 2. Or
Oh, okay. All right. So
yeah, like, I don't know.
no. Jack, you're getting ahead. You got some ESP going on. What's the multiplicative identity? I just like saying multiplicative. Same idea, same reasoning. What do you multiply by to keep something the same?
1.
1. 4 times 0 is 0, so it can't also be that. But 4 times 1 is 4. Negative 7 times 1 is negative 7. Anything times 1 is that thing, so it maintains its identity. We stopped there for a second. There really is nothing amazing here today. It's just that word that we associate, right? It's that word, just to understand what the word means. So when I say additive identity, you know I'm talking about 0.
It's just the idea of adding 0 to a number.
Keeps its identity.
Okay.
Multiplying a number by 1.
And then that's just the number, and it multiplicative identity represents
Yeah, it's
1.
not easy to say.
It represents 1, and then additive identity
Number
represents 0.
Beautiful.
Okay.
Beautiful. So if you see that in the homework, if they talk about additive identity, you know they're talking about.
Was that multiple identity be the same for the negative side too?
Totally. Well, what's negative 6 times 1? Negative 6. You with me?
Yeah.
Negative 1 can't be the identity because when I multiply something by negative 1, I change its sign. It's become the opposite of what it used to be. So that can't be the identity. Cool, I like it. We always get 2 classes in one.
That's awesome.
Okay, so there's one level of things, and I want you to realize that's pretty straightforward. Right, it's just the word identity. That's the key here. Now, right off the heels of this, we get the idea of inverse, which is another way of saying opposite. So again, we have an additive inverse. And really, if I just ask you, what's the opposite of 3? There's kind of 2 ways you can answer me, but the most common way is for someone to say negative 3. And so what do you get when you add 3 to negative 3? You get back to the identity. So the additive inverse is the number that I add to something so that it becomes the identity, so it becomes 0. And you guys know this. If I said, what's the opposite? Now you know the word inverse means opposite. What's the opposite of -5? Well, what's the opposite of -5? Positive 5. You got it. I got you. Right? Because when you add those together, you get 0. Yeah.
So, just make 0?
Yeah, just make 0. So the big key thing here is, Jackie, the word inverse, right? So new word for us. So the additive inverse is
Inverse.
the negative of the thing, right?
He's making the
So the
number
additive
0.
inverse of A would be -A, whatever A is.
To make it 0.
So what's the additive inverse of 1/5?
Negative.
Negative 1/5. Because when you add 1/5 to -1/5, you get 0.
0.
What's the additive inverse of -12.7? Positive 12.7. That's crazy, all right?
So inverse is that. Okay.
So additive inverse is the negative number, the opposite sign number, right? Change the sign. So if it's negative, it's additive inverse. It's the same number with the positive sign. How we doing? Nothing major there still. It's really just the word that we have to understand what it means. Yes, ma'am?
So you're basically putting two opposite signs together with the same number and making 0.
Yeah, if it was negative, its additive inverse will be positive then. If it was positive, its additive inverse is negative then. Because those two will cancel each other out. I like it. Cool, not too bad.
I know, right? Just remember the name. That's what I'm going to fuck up.
So now, what about multiplicative inverse? So how can we start to investigate that? Multiplicative inverse must be the number that I would multiply something by
To 1?
to get back to 1. Beautiful.
Get back to 1. Okay.
So the multiplicative inverse, so for example, if I have 4, what do I multiply 4 by? And why is it 1? Because I want to get back to the identity for that operation. Right, so an inverse is the thing that gets me back to the identity. What's the opposite of 4 multiplicatively? It can't be -4 because 4 times -4 is -16. That's not good. 4 times 3 is 12. I need something that I multiply 4 by to get back to 1. Well, what do you actually do to 4? That's -16, right? What do you actually do to 4 to make it 1? Divide by 4. So 4 divided by 4 is 1. So 4 times... So if 4 divided by 4 is 1, 4 times what? When you divide, you multiply by the?
Opposite.
1/4. So 1/4 would be 4's multiplicative inverse.
Math.
So what is multiplicative inverse another name for reciprocal?
It's just divided by the number over 1.
I like it. Yes. So some of you guys, so many words flying around. But when I say multiplicative inverse, it really does just mean reciprocal because that's what I would multiply by to make something become 1.
Can you just like divide it, like do the same thing, but like if it's like 6, you do it 6, 1 over 6.
Yeah, totally.
So just put a 1 over.
Yeah, so let's do a few. So
Divide
a 6 would be 1 over 6, right?
over 1.
What would the inverse be for 1/5? 5 over 1, or just 5? What would the... Is everybody with me?
What about this?
No.
Or negative?
So let me slow down. So if I said, what is the inverse, multiplicative inverse of 1/5? It's the number that I multiply 1/5 by to get to be 1. So it would be 5. It's always going to be the reciprocal of what I'm telling you. Because what is 1/5 times 5? What happens there?
1.
What happens to the 5s?
It cancels out
What is,
the
yeah,
one.
1/5 times 5, these 5s cancel. So I do get back to 1. So multiplicative inverse is the same idea as additive inverse, but it must be what I multiply by to get back to the identity, which is 1. So now, after discussing all that, we can realize the shortcut is multiplicative inverse just means reciprocal.
Okay, yeah, one question. It might throw you off a bit.
All right.
These 2 5s cancel out, right?
Yeah.
That's with the cancellation of the same numbers, right? Well, how come the 2 1s don't cancel out and make it 0?
Well, when we say the 2 5s cancel, what do we really mean? They don't make 0. What is 5 divided by 5? Now watch. What is 5 divided by 5? 1. So when we say 2 numbers divide and cancel, they don't become 0. They become 1. Yeah, so 1 divided by 1 is also 1. So that's why there's a leftover 1 there. All right.
Yeah, no.
I like it. I like it. So this is stuff we already knew. We're just kind of packaging it up and calling it something. You have to know what they mean when they say this, though. What about this? What's the multiplicative inverse of 4 over 9? It's crazy. And let's investigate. It's supposed to be the number that when I multiply it by this, it becomes 1. Right?
904.
Multiplicative inverse is the number that when I multiply it by the original number, it becomes 1.
9 over 4?
Yeah, I know. So people always say, but so when I do multiply by 9 over 4, what happens? The 4s become 1.
Right.
And the 9s become 1. So again, whatever the thing is, you reciprocate it. So what's the one last one here?
Same thing for a decimal, right?
Exactly.
Okay.
So now watch. So to be careful with decimals, since you brought them up. And they are in the homework. Now, I'm not going to accept this guy's multiplicative inverse to be 1 over 0.2. Why wouldn't I take that? Because 1 over 0.2 is a mixture of types of numbers. So a good way to start with this thing is to turn this into a fraction. If I know what this fraction is, I just have to flip it. So what is 0.2 as a fraction? 2 tenths. And of course 2 tenths is
10 over 2.
reduce.
1 out of 5.
So the inverse would be
5 over 1.
5 over 1. Now if you do this inverse, what's the inverse for 2 tenths?
10 over 2.
10 over 2, but that reduces to 5. I mean, you got to reduce. I was going to say you almost can't go wrong, but don't tell me it's 10 over 2. That's freaking 5, right? Actually, simplify your answer. I like it. How we doing? So multiplicative inverse just means reciprocate. Make the reciprocal. Flip it. So what about this? Here's where you got to be careful. Negative 11 twelfths. What's that guy's multiplicative inverse? Don't overthink it. A multiplicative inverse just means take what it is and flip it. Did I say a word about the sign? No.
So ignore the sign.
Well, don't change the sign is really the thing.
Oh.
Well, if you flip negative 11 twelfths, you get negative 12 over 11. Do you guys see why that negative sign has to be there? If it wasn't there, you would get negative 1. I want 1. So there's got to be negative so it can cancel. So just reciprocate. So additive inverse, just change the sign. Multiplicative inverse, just reciprocate. Yes. Yes.
For the D, so you put like 2 over 10, so you just do the reciprocal and that's going to be the inverse.
That'll be the inverse. You get 10 over 2, and then you can reduce that to 5.
Okay.
Yeah. I like it. So here, let me let you guys try this here. This will be nice, because normally when I let them work on me and D work together, but I don't have time to like move around the room. So now maybe you guys can work together on this here. Oh yes. So here's the number. I want the additive inverse, and I want the multiplicative inverse.
I didn't hear that. Okay.
So for example, if I gave you 7/4, the additive inverse would be negative 7/4, and the multiplicative inverse would be
Reciprocal.
4 over 7. All right, so you guys do these.
Yeah, just a second. Let me write it down.
Did I write it big enough? Can you see them? Okay.
Oh.
Yes.
Oh yeah, it's negative 5. So what would the additive inverse be for negative 5? Yep, cool. You're good, man. The positive 5, yeah. Yep. And for negative 5, what's the multiplicative inverse? Good, there you go. Keep the negative 1/5, yeah.
I didn't finish.
You guys start to realize that the additive inverse is always easy. Whatever the sign is, change it. Multiplicative inverse is where things get weird with like decimals and stuff.
Like that number 2, that 5, that negative 5 on the multiplicative.
Oh, for 11 seconds, what's the additive inverse? 11 seconds. Got it. Negative 11 over 7. Yep. Negative 11 over 7. Yeah. What'd you say? I'm sorry. What did I say? So 11 over 7. Negative 11 over 7. 11. So now what's the multiplicative inverse of 11 over 7? 7 over 11. Yep. So that word opposite is kind of evil because there's 2 different opposites it could be. So it's or 7 over 11. So you can just no, not equal. They're certainly not equal to each other. It's a totally different number, but it's the reciprocal. All right, catch up to you guys. So additive inverse. Let's just go through those first. It's probably the smart way to do this. I think there's problems like this in the homework. Additive inverse of negative 5? 5. Why? Now see, I was just talking to you about that word opposite is a little evil. Because there's 2 different opposites it could be. Right? This is opposite, and so is changing the sign. So additive inverse, you just change the sign. Negative 5 plus 5 is 0. So it is the additive inverse. I like it. It's what cancels that guy out. 11 over 7, what's his additive inverse? Careful. Additive inverse. I'm just going to do all those first. Negative 11 over 7.
I'm yellow. Huh? Oh, wait.
I thought you flipped the sign. Oops, that's a good one.
What do you add to 11 over 7 to make it become 0? Negative 11 over 7. Yeah. So don't mix the two different things together.
Can you?
And what about 0.03? What's its additive inverse? Negative 0.03. That's crazy. It's almost too easy to believe. Additive inverse, you just change the sign. That's all you do, because that would guarantee that they'll cancel each other out. All right, now multiplicative inverse of negative 5. What's the multiplicative inverse? What do you do to negative 5 to make it the multiplicative inverse?
1 out of 5 negative.
Okay, sure. So negative 1/5. So as long as a number starts off as a integer or a fraction, then multiplicative inverses aren't that bad because you just got to flip them. That's all you got to do. And how do I check that? Real quick on the side here. How do I check that these are correct? What's supposed to happen with the multiplicative inverse? When I multiply, they're supposed to become 1. So what is negative 5 times negative 1 over 5? What happens to the 5s? They go to 1. And what happens to the negatives? They cancel. So I'm just left with 1.